Welcome back to School of Physics. Another lecture. Today, as you can see the heading, I am going to discuss few problems on the laws of motion which we were discussing earlier. We have discussed the law of inertia, that is first law of motion, second law of motion, and third law of motion. With that, we also discussed the impulse and other stuff which was concerned and dealt with these concepts. And we also discussed the coordinate systems, which include orthogonal coordinate system and plane polar coordinate system, that is polar coordinate systems. We discussed all these kind of stuff in the earlier lectures. So today we are going to deal with few problems or onto these very concepts. Let us take the first problem. Problem number 1. Consider, it is actually dealt with the second law of motion, third law of motion, and furthermore in other problem sets we will discuss other ideas as well. So here, first problem, consider two objects, consider two bodies on a surface. This is surface, but this is frictionless surface. Keep that in mind, it is frictionless surface. This is the first problem. We are considering a frictionless surface, and on that we are having two bodies. This is body 1 with mass m1, and second body is attached with it. It is smaller body of mass m2. The surface is frictionless. Two bodies are side by side placed onto this very surface. And suppose that we are applying in this direction, we are applying a force on body bigger body, that's on body m1. So we have to calculate, this is the horizontal force, keep that in mind, acting over on this very body. What is the problem here? We have to find the force of contact between m1 and m2. This is the problem to be solved. So we have to find the force which is acting between the bodies m1 and m2, not this very force. This very force is acting on the first body only. So since if we apply the force on this very body, that will result in the motion of the second body as well, from the second law of motion and the third law of motion. How that is applied, I will tell you that very thing in a moment. So we have to calculate that very force which is exerted by body m1 onto this very body m2. So that will be the force of contact. So actually we have to find the force of contact. Let us say we denote this very force of contact by F prime. Okay, so how to deal with this very problem, the solution part of this very thing. First and foremost, draw the free diagrams. Okay, draw the free diagrams. Draw the free diagrams. For example, the mass m1, this very body is here. Since the surface is frictionless, so it will not exert any frictional force onto these very bodies, even though these are set in motion on this surface, but it will not exert any force to retard its motion because the friction is absent here. We are considering the frictionless surface. So only the forces which are acting on body m1, this is the body m1, will be first and foremost this very force acting horizontally like this. So this is the force acting on this F. Another force, since it has mass m1, so there will be a downward force exerted by gravitational force, which is the gravity of the earth. Okay, so gravity is always downwards, so we have to keep in mind this must possess some weight, and that weight will be given the downward force equal to mg, that's m1g, the mass of the body, m1 multiplied by the gravity. But we see that this body is not set in motion in this direction. Say this is the direction y-axis, this is the y-axis, and this is the x-axis. Since no motion is in this direction, no motion is there. Okay, no motion, only the motion is seen in this direction, that is the horizontal direction, x-axis only. So that means this mg, that is the weight, must be balanced by some force which is exerted by the surface when these come in contact, which is exerted in the opposite direction, to that of this weight. Since the weight is downward, so there must be a balancing force, which is the reactive force upwards, which must be equal to that of the weight of this very body, and we represented that reactive, the normal force, as R1. So this R1 must be balancing m1g, because there is no motion seen along y-axis like this. So no motion is seen along this very axis, so these must be equal to each other. Okay, now another thing, we have another body here, m2. This is m2. Similarly here, downward force is gravity, so there must be m2g, which is the weight of the body. And this weight of the body, since there is no motion along the y-axis, so it must be balanced by the upward force, which will be normal force to this, and which will be the opposite to that of the weight, a kind of reactive force, denoted by, we will denote it by R2. So these two must be cancelling out each other. Now there is another force. Since these two bodies, m1 and m2, these two bodies are in contact with each other, so there must be some normal force acting between these two also. And if this is the point of contact between these two bodies, say, so if body m1 is exerting some force on this very body, some normal force on body m2 as n, similar force must be, say for example these two are at rest, okay, even though these are at rest, and then also force of contact will be there, this normal force will be there, because when our two bodies are set in contact, there is some contact force. If this very exerts more force onto this, then this will be set in motion like this. If this exerts more force on this direction, then it will be set in motion like this. So that means there will be always this contact force, and from the third law of motion, there will be equal and opposite normal reaction, normal force acting on m1 also. So this n and this n cancels, so this very contribute nothing to the motion, overall motion of these two bodies. R1 cancels m1g, R2 cancels m2g, so these contribute nothing to the net acceleration or net motion of these two bodies. So we will find that the only force which is contributing towards the acceleration of these two bodies will be this F. Okay, because this F is not cancelled out, all other forces are cancelled out, so F is the only force. So this F is the only force contributing. This F contributes to the combined acceleration of the two bodies, M1 and M2. Okay,